developers strive to remove memory leaks from their application, they tend to focus the majority of their energy on the most impactful issues. However, one of the biggest, most frightening leaks are often hanging around in their code base going unnoticed. My name is Colt McCandless, and one of the worst things that can get leaked in your Android application is a view object. For the most part, views are simple little gizmos that help us update the screen and display information. We generally don't think of them as potential memory hogs, which, I mean, is kind of true. By themselves, views aren't much of a leak problem. Rather, it's what they reference that can cause a horrible leak situation. Remember that the garbage collector system in Android can only reclaim objects that are no longer referenced by anything else inside of memory. A leak is an object that is no longer needed, but there's still a reference to it somewhere in the system. This problem can cascade when that object references other objects, and those objects reference other objects. None of them in the entire chain can be removed from memory because of the existing references from that root leak. So here's the problem. Views contain a reference back to the activity that created them, and activities in turn tend to reference lots of internal objects and other memory items. This is why a leaked view object is such a big issue. When a view leaks, so does the activity it references and all of the other data involved. Basically, the entire activity sits around in memory, which can be an extreme problem in certain situations. For example, when the user rotates their device, a configuration change will be triggered, causing the current activity to be destroyed and a new instance of it to be loaded into memory. But if a view from that first activity was leaked, then the original activity can't be cleaned up now, and so it'll just basically sit around hogging memory that should be given to the new activity instead. Now, imagine if this happens and the user rotates their screen back again. Suddenly, you've now got 3 separate instances of an activity in memory, all fighting for space. So, avoiding leaking view objects should be the top priority for your memory management policy. To that end, here are some simple patterns that you should watch out for. Number 1. Don't reference views inside of async callbacks. That async event may execute at some point in the future where things aren't ideal. I mean, in one situation, the activity may have been killed before the callback is triggered, but the view and the activity as such will be kept around until the async function completes and releases its reference to the view. And in a worse situation, your callback may be executed after the view object has actually legitimately been destroyed, thus dereferencing an invalid object and causing your application to crash. Really not that important for performance, but you know, the whole crashy thing tends to shine bad on users. Anyhow, number 2, don't reference views from static objects. The issue here is that static objects persist for the lifetime of the entire process that's running your app, which, by the way, is not the same as the lifetime of the activity that declares the static object. As such, having a static object reference to a view can cause issues when the activity is destroyed, say during a configuration change, because the view is still referenced by the static object, and the static object then of course references the activity as well. Neither the view or activity will ever get cleaned up because of the lifetime of that object. And number 3, avoid putting views in collections that don't have clear memory patterns. For example, using a weak hash map object to store views as values. Since weak hash maps store views as hard references, you can end up in a bad spot anytime something destroys those views. This type of weak hash map behavior has led it to be nicknamed the leak hash map. Leak, because it's the weak hash. Now, if you're ever wondering where your memory is going, make sure to check out the allocation tracker tool inside of Android Studio. If you see content from an activity that's not supposed to exist, you might need to take a hard look at your code. And taking hard looks at your code is what Android performance is all about, which is why you should check out the rest of the Android performance patterns videos and check out the Google Plus community for other great tips. So keep calm, profile your code, and always remember,